Today we're going to be talking about the Unit 2 spectral line simulation, just to make sure that we got all that we were supposed to get out of it. And that's what we're looking at right now. I've got it on the continuous stream of electrons just so we can keep seeing a repeat over and over again. The electrons are being emitted from this plate and they are crashing into the atom. Obviously, if we move the atom out of the way, we're not going to see any of these jumps happening anymore, so the electrons have to hit the atom. The electrons are coming in with a certain amount of energy. That electron hits the electron in the atom, and as a result we can see that on the collision, and notice the number on the atom is showing us what state the electrons, or what what principal energy level the electron is in currently. So it goes from 1 to 2, 1 to 2, and back down to 1, and so forth. So anyway, every time an electron hits, an electron absorbs the energy. So an electron within the hydrogen atom absorbs the energy from the electron it's hit with, and then once it goes to drop back down to its ground state, that electron releases energy. So we can see these photons of energy, and these are all violet colored coming out in the depiction. Okay, so how can the energy at collision arrow be manipulated? So you see this energy of collision, and so notice if we move this atom closer to the electron source, that actually lowers our energy at collision. So at this point, the electrons that are hitting the atom, they don't have enough energy to make the electrons inside the atom make that jump. And then as we move it back, we eventually, and if we're here, that means that the electrons are hitting with enough energy to make the jump up to 2. Notice if I pull it back even further, so that, let's say I have my energy at collision right above energy level 3, then I can see jumps potentially going up to 3 or up to 2 and then back down again. Notice the other thing we can do to change the energy at collision is the voltage. Now again, the voltage is applied to these plates, and it might seem kind of weird then if we move it closer. You'd think that when we're colliding the electrons closer to this plate of origination, that the energy would be greater on impact, but actually because the electrons are being attracted to this plate over here, they're going to be speeding up. So you notice they're going slower over here and they start to speed up. So that's why we get a higher energy of collision over here closer to this plate. And so if we increase the voltage, we also increase that energy of collision. So those are the two ways that you can do that. And light's produced when, so notice it's only being produced when these electrons that have absorbed energy are jumping back down to lower energy levels. So this squiggle line here, this is representing that it's just a amount of energy that's not visible. Notice when you see the jumps from like 3 to 2, though, it's showing as like a red squiggle. So going from 3 down to 1, it's still this wavy, but when we go from 3 to 2, it's red. If we scooch this up a little bit further, you can see, eventually should be able to see some of these other jumps like we saw, like that bright blue, different color. So again, depending on which energy levels they're jumping from and to, that's how the light's being produced, is that the energy released from the electron that is jumping back down to a lower energy level. Obviously then, this ties in with what we talked about in class with the fact that certain amounts of energy have certain wavelengths, and if that wavelength is in the visible spectrum, then we can see it. And also the fact that we see the electron is only jumping between the energy levels. Run this in slow motion. Electrons are only jumping between the energy levels, so it's never stopping here or stopping here or stopping here. And so that again ties into our idea of the quantization of energy, which is what Bohr was saying about the atom. And in question 6, we were asked, is it possible for a single electron to collide with the atom of hydrogen and result in more than one photon or particle of light being emitted? If we have our energy of collision up very, very high, that is possible to happen. So we actually just saw that happen right as I was talking. The electron went up to 5, then jumped to 4, and then jumped down to 3. So it can emit any quantity of energy between for a jump down. So if I'm going from 6 to 5, there's energy that could be emitted. If I'm going then from 5 on to 4 or 5 to 3 or whatever, and another amount of energy can be emitted as well. And if we take a look at our next set of questions, so we were supposed to get these spectrums completed, spectra. And so we have hydrogen, mercury, sodium, and neon. And so this one's for hydrogen, this one's for mercury, this one's for sodium, this one's for neon. Based upon your observations, which colors of visible light are highest in energy? So again, we should have noticed the violet color being highest in energy, because we can see that when the violet color is released, that's as a result of an energy jump between a greater distance of energy levels. So, like going from the higher energy levels down to a lower energy level, and making a larger energy jump is where we get the violet lines from. For number 2, citing observations from the model, explain relationships between wavelength and energy. So we see that the more energy with which the electron strikes the atom, the larger the possible energy jumps for the electrons, and therefore the shorter the wavelength of light that is released. So we can see the wavelength of light, the violet being released when we've got the larger energy jump. So if we're hitting the atom with more energy, we're going to see those shorter wavelengths being released, versus with the lower energies, the electrons are releasing longer wavelengths. If we take a look at our last page, some answers to these questions, so you can take a look at what you have and what I have here. And so just check your answers. You can pause the video if you need to. And then I'm going to scroll down. You can check the bottom half and see how you did.